Section 8.2 is solving exponential equations and inequalities. If you have b to the x power is equal to b to the y power, and in other words, if your bases are the same, then your exponents will be equal to each other. Example 1, 2 to the x power is equal to 8 to the third power. Your goal is to get your bases to be identical. Now, on the left side, we have a base of 2. On the right side, we have a base of 8. We need these bases to be the same. We can't do anything with the 2. That stays. But look at the 8. Can we have a base of 2 to some power give you 8? Yes. What? 3. So 2 to the third power gives you 8. And then we have that 3, so then we have that 3, so we have to put a parentheses, power of a power. So this 8 gets replaced with the 2 to the third power. And then we bring the 3 down. Now, power of a power, we do what with the exponents? We multiply. So that's 2 to the x power is equal to the 9th power. Now that our bases are equal, we just drop the bases and put our exponents equal to each other. So x is equal to 9, and that is the answer. Now we can check this very easily by plugging it back into the original problem. So that's 2 to the 9th power is equal to 8 to the third power. Get your calculator out and evaluate what is. So looking at the left side, we need to change that 9 to have the same base as the right side. The right side has a base of 3. So can we change 9 to have 3 to some power gives us 9. What is that? Squared. So I'm going to change this 9 to 3 squared. And then I just bring down the 2x minus 1 is equal to 3 to the 6x power. Now our bases are identical, so we just put our exponents equal to each other. So that's 2 times 2x minus 1 is equal to 6x. And then this is simple solving equations. Do the distributive property. We're going to solve for x. So now we're going to solve for x by subtracting 4x on both sides. So that's negative 2 is equal to 2x. And then divide both sides by 2. So negative 1 is equal to x. Did I answer your question?
I just solved it differently. Was the only thing. But it's fine. Because we have the same answer.
All right. Example 1c. 4 to the n minus 1 power is equal to 64. Once again, we want our bases to be identical. We don't want to change the 4, we want to change the 64. What base, it's 4 to some power give us 64? Because how do you know you want a base of 4? You could think of 64, that's 8 squared is 64, and 4 to the third power is 64. So could you use either one? No. We want our bases to be identical, so we have to use the 4 to the third power. If you use 8 squared, then your bases won't be identical. So we're going to turn the 64 to 4 to the third. Now, once our bases are identical, we put our exponents equal to each other. And then solve. So 2n is equal to 4, divide by 2, so n is equal to 2. And once again, should you plug it in and check to make sure that the left side equals the right side? Yes. Okay, y'all do this one. So that's 5 to the 5x is equal to 5 to the third, and then we put in parentheses the x plus 2. Our bases are identical, so we put 5x is equal to 3x plus 6. As I bring down, can I distribute all at the same time? Yes. Subtract 3x for both sides. So that's 2x is equal to 6. Divide by 2. So x is equal to 3. You don't have to copy this entire problem down, just copy the very first sentence down, please. Kristen starts an experiment with 7,500 bacteria cells. After 4 hours, there are 23,000 cells. Write an exponential function that could be used to model the number of bacteria after X hours if the number of bacteria changes at the same rate. Okay, so we want an exponential function. What is the formula for exponential? Y equals A times B to the X power. Y is the total amount. It starts with an experiment of 7,500. So that is your A. If there are 23,000 cells, that's the total number of cells, so that's going to be my Y value. Times our B, we don't know the B. Do we know our time? 4 hours, so that's B to the 4th power. Now we have to solve for a B, so what would we have to do first? We're multiplying by 7,500, so to get rid of it, we have to divide by 7,500. Now, when you do that, I would go the third place value. So that's 3.067 is equal to B to the 4th power. Now we want to get rid of the 4th power. So the opposite of doing something to the power is doing the root. So we want to take the 4th root. And remember, to take the 4th root, you hit 4, math, go down to the 5th one, and put in 3.067 equals. And again, you can round to the 2nd place value, the 3rd place value. It really doesn't matter. It's up to you. I rounded to the 3rd place after the decimal. So B is about equal to 1.323. That is my B. Example B says, how many bacteria cells can be expected in the sample after 12 hours? So what we're going to do is we're going to write our equation down, and this time we are trying to find our Y. We're trying to find how many bacteria cells. We don't know our Y, but we now know our B. So we can plug in, our A stays the same, that's 7,500, and our B is 1.323, and our X, our time, is 12. Can we put all of this in the calculator all at once? Yes. If you have a graphing calculator, you can. If you have a scientific calculator, you have to do bits by itself. So everyone put that in the calculator. Because we are dealing with number of cells, you cannot have a fractional part of a cell. You got to round to the nearest whole cell. So it is about 215,665 bacteria cells. Use some common sense on what you would round to. If you're dealing with money, you round to the nearest penny. If you're dealing with something whole, you got to round to the nearest whole number. Now we're going to talk about compound interest. Compound interest is very, very, very important. You will use this in your life, especially if you want to make investments. They use the compound interest formula for calculating how much you earn. A stands for the amount, is equal to P, and P stands for your principal, times 1 plus your rate, and rate is a percentage rate that you will have to put in decimal form to calculate it, over N. And N stands for the number of compounding years, or compounding periods, times NT. And T stands for the time in years. Number of compounding periods in 1 year. So there's the formula. You must write the formula every time you use it. Don't just write it one time at the top of your paper and never write it again. If you have 10 homework problems where you have to calculate the compound interest, how many times are you going to write that formula? 10 times, every single time. All right, example 3A. An investment account pays 4.2% in annual interest, compounded monthly. If $2,500 is invested in this account, what will the balance be after 15 years? First thing we do is write the formula. A is equal to, P times 1 plus R over N to the NT power. Now let's plug in what we know. The principal is the amount invested. We invested $2,500. Times 1 plus the rate is 4.2%. Now 4.2%, we must change it to a decimal and drop the percent sign. So it's 0.042. Compounded monthly. So that's every month. How many months are in a year? 12. So my N is 12. To the 12 times 15. Now, with your calculator, I'm going to do this in parts. I'm going to do 1 plus 4 all of this in the parentheses, times 1.0035 to the 180 power. And this is dealing with money. So what place value are we going to round to? To the penny. $4,688.87. And this is money, so put your dollar sign. So basically what that means, if you put $2,500 in an account and you never touch it, you forget about it, and 15 years later you're like, oh, I forgot about this. Your $2,500 is now how much? 4,600 and some change. Pretty good, huh? Yes, almost 50%. That's a very good interest rate. Run for it, absolutely. Okay, example 3B. Y'all try to do this one by yourself. What do you write first? The formula. Compounded twice a month. How many months are in a year? 12. So how many times will it be compounded in 1 year? What is 2 times 12? 24. 24, and after 20 years. Okay, put this in your calculator. So you get $127.12. Is that a good interest rate? No. It's $100. What's wrong with this problem? Now, inequalities are exactly the same as if it was an equal sign. B to the x power is greater than b to the y power, then x is greater than y. Or if b to the x power is less than b to the y power, then x is less than y. And don't forget, after we solve, because it's an inequality, we are going to put our answer in interval notation. Now let's first look at our bases. We have a base of 16 and a base of 8. I don't have anything in common, but I can manipulate them to have a base of 2. 2 to the 4th power is 16. And 2 to the 3rd power is 8. So there are my bases are identical. So now I put my exponents, instead of equal, they are an inequality, and I can go ahead and distribute and get 8x minus 12 is less than 3. Add 12 to both sides. Divide by 8. So x is less than 15/8. I'm going to put that in interval notation. Interval notation is negative infinity to 15/8. I don't have to turn it into a mixed number unless I was graphing. Example 4b. We need to turn look at the 243. We know by looking at the left side, the base is 3. So that kind of gives you a little hint that 3 to some power is going to give you 243. You can look at your index card or you can play around with your calculator. Okay, so that's 3 to the 2x minus 1 is greater than, now right here that's 1 over 3 to the 5th. But my goal, I've got to get this base on top. Well, it's going backwards. If it's on the bottom, then that must mean it was a negative to where we moved it to the bottom, so we're going to go backwards. So it's going to be 3 to the negative 5th power. And then we take our exponent, so that's 2x minus 1 is greater than negative 5. Add 1. Add 1, divide by 2. So we get x is greater than negative 2. It's a greater than or equal to, I forgot my equal sign. Now, when we go to put it in interval notation, it's negative 2 with a bracket to positive infinity. Okay, y'all do example C by yourself. So we put each one, left side equal to the right side, subtract 2, so x is greater than negative 7. And interval notation is negative infinity to negative 7 with a parentheses. And that is your assignment.